Thank you for joining us for the Forest Drought Response Index evaluation webinar. We look forward to getting input from you related to this new tool, and I'm going to hand it over to Sagai to introduce himself and start.
Okay, thank you. Good afternoon. My name is Sagai Taddesa. I'm a research professor of applied climate and remote sensing at the University of Nebraska-Lincoln. I'm also geospatial coordinator at the National Drought Mitigation Center. Developing a new drought monitoring tool called Forest Drought Response Index, or ForDRI, is one of the tasks of our USDA project. The lead PI is NDMC Director, Dr. Mark Svoboda. I'm one of the co-investigators and leading these specific tasks within the larger USDA project. Our goal and objectives of this webinar is part of the evaluation process of ForDRI on several forest regions in the United States. Today's webinar will focus on the southern and southeastern US forest regions. After a brief introduction of ForDRI, our objectives today are to collect feedback to evaluate the general accuracy or performance of ForDRI using the recent or 2023, 24, and 2016 case studies, gain understanding of how ForDRI information could be used for monitoring drought over the forest regions and decision making, look for existing gaps that the ForDRI might address in forest drought monitoring or management, and identify any specific applications that could use ForDRI information. Your evaluation or feedback will be incorporated into the operational monitoring of drought impacts on forests for the United States. Today's agenda is we'll start with brief introduction on the USDA project by Dr. Mark Svoboda. Then I will do short presentation on ForDRI. Ian Radcliffe will present a short demonstration on the ForDRI Dynamic View website. We will conduct a quick survey questions, Qualtrics. Then we'll do the breakout groups discussion for about an hour on the case studies. After the breakout group session, we'll return to the main room. Then we'll have quick surveys on products, quality or accuracy. Finally, we will have a general discussion. Dr. Brian Wardlow will lead the discussion. We plan to adjourn at 3 p.m. Eastern. However, if anyone would like to stay and ask more specific questions or would like to give more inputs, we allocated an optional additional hour. So without further ado, I would like to invite Dr. Mark Svoboda to give a brief introduction on the overall USDA project. Mark?
Yeah, thank you, Sagai, and thanks to all of you for giving us some of your precious time to participate in this. We're really excited about trying to fill a gap in our drought monitoring capacity across the United States by targeting forested areas. We've got a little bit of experience in that through these overarching USDA cooperative agreements. They are with the Office of the Chief Economist. And we have had dozens of these over the last several years. And in more recent times, we've had several examples of projects by dealing and reaching out to the directors of the various climate hubs. And this one actually originated in the Northeast as sort of a pilot with Dave Hollinger and Sagai. And due to interest by USDA and by others within Forest Service and at the other climate hubs, you can see here today, yes, we're focusing on the South and Southeast, but this is spread countrywide, and our intention is to take this operational across the United States on October 1. So today is the first kickoff of a series of validation workshops with the intent of getting critical feedback from experts in this area. You folks are the experts on the forest ecology side of it. And our job is to take that and fine tune it and make it better as we roll it out operationally. So again, really excited to kick this off and fill a niche. And I think USDA is excited about it too. So we look forward to working with you. That's why that survey is so important, is to get your feedback, feel free to don't hold anything back, right? So the breakouts are there for you to express opinions on whether you think this passes the sanity check, the eyes and ears check, if you will. So we want to hear the good, bad, and the ugly. So with that, I'll turn it back to our team and look forward to your feedback. Thanks. Bye.
Okay, what I'm going to do next is briefly introduce you what ForDRI is, including its inputs, methods, and products or maps, and then we'll evaluate the ForDRI maps using case studies. First, I would like to acknowledge our research team that are working on this specific task. The NDMC is leading the ForDRI project. In addition to UNL team, David Hollinger, former director of the USDA Northeast Climate Hub and the US Forest Service, was one of the collaborators on this research until he retired last year. We'd like to have more collaborators from climate and forest service community who are interested on our ForDRI research. Let us know if interested. Now, to give you a brief background, as you know, monitoring drought impacts in forest ecosystems is a complex process. So we are making an effort to integrate several drought indicators that would help in monitoring the impact of drought on forests. Our research project's main objective for this task is developing Forest Drought Response Index, or ForDRI, that could help in identifying and monitoring drought impacts on forests. So ForDRI is expected to detect areas prone to tree stress that could help in taking appropriate mitigation measures. ForDRI is expected to help users, such as US drought monitoring map authors or the drought experts, and forest managers in characterizing and monitoring drought across forested areas of the US. We are using several approaches, including machine learning and big data analytics to integrate climate, hydrologic, biophysical, and vegetation conditions or indices and indicators to build a ForDRI tool. The tool is specifically designed to be applicable to forest ecosystems in the US. This slide shows the conceptual method and steps to develop the ForDRI. The concept of a ForDRI is to combine important atmospheric or hydrological variables together, that is using a multi-indicator or convergence of evidence approach so that we produce a better drought index for forests than any of each individual drought indices used alone. Currently, our ForDRI tool is composed of three major components that include satellite, climate, and biophysical parameters. So the first step is input data collection and processing. Here in the left side, you see 12 input variables that the NDMC used to develop the ForDRI model for the US. The input drought indices include MODIS-based NDVI. This is replaced by VIRS-based NDVI for the operational product because the MODIS dataset was discontinued since February 2023. GRACE-based groundwater storage at 1 meter depth. Standardized precipitation indices at 9, 12, 24, and 60 months time scale. Standardized precipitation evapotranspiration indices at 12, 24, and 60 months time scale. NLDAS NOAA soil moisture, 12 months evaporative demand drought index, or EDDI, and vapor pressure deficits, or VPD. These input data are reformatted, reprojected, resampled, and masked or clipped for forested areas to build the database. All input data are also standardized to be consistent with the integration of the datasets. The next step is combining these variables based on weights. That's their potential contribution to the drought event. On integrating the inputs, there are several approaches or methods that we have implemented in research mode to determine the contribution or the weight of each input variables objectively. For the current ForDRI model, we have used PCA-based methods to determine each input's weight. We are also investigating other machine learning tools for future improvement of the model. Finally, we calculate the standardized ForDRI values to produce ForDRI maps at weekly time steps. After producing the ForDRI maps, one of the very important and challenging tasks is evaluation of the modeled product. We use different statistical techniques to compare with other drought products for evaluation. I'll show you some of the examples later. In addition, we need feedback from local experts and users to compare our ForDRI with ground observations. Our research team believes that this evaluation process would help us or be used to improve the ForDRI. That's the main objective of today's webinar. Well, the last step is producing near real-time weekly operational ForDRI map and web delivery of the ForDRI maps or the products. We have recently launched a ForDRI website that we'll discuss on it later during the breakout session. This map shows an example of ForDRI maps generated for January 1, 2024, the current year. As you can see on the map, the ForDRI values are displayed on only the forest areas, as I mentioned earlier. To interpret the maps, the ForDRI values are classified into 8 categories, as you can see on the legend. The classes include extreme, severe, moderate, and pre-drought categories in the dry side to identify the stress on forests. For our evaluation of over the southern regions, we have extracted the 3 forest regions, as you can see on the right, to consider the recent forest conditions over the southern region. We have ForDRI maps that starts from the fall of last year to last week, 18th March 2024. It's updated every Tuesday, and the next one would be tomorrow. We will show you those maps during the breakout session. Because the 2023-24 ForDRI maps show the recent forest conditions, which is less than 6 months, our expectation is that many of you could have a knowledge and real-time experience to let us know what's happening on the ground, especially in your local area, and compare your observations with the ForDRI maps. In addition, to consider past drought year for a case study, we have produced the weekly 2016 ForDRI maps for this webinar. This slide shows an example of ForDRI generated on November 28, 2016. We will show you the other weekly maps for the 2016 that you could closely look into and provide your feedback during the breakout session. We used qualitative and quantitative methods to evaluate the ForDRI. For qualitative analysis, as an example, we compared the ForDRI with the USDM US Drought Monitor for the selected drought years. For example, on this slide, ForDRI and USDM maps are shown for the week of January 1, 2024. As I mentioned, this comparison is qualitative assessment that's mainly designed to do a sanity check. In other words, we check if there is nothing out of the ordinary on the ForDRI maps in terms of drought occurrences, intensity, and their patterns. In addition, you can see that the gray color on the ForDRI maps that are non-forested lands, for example, agricultural, rangelands, water, and urban, which are not the focus of the ForDRI. In other words, ForDRI focus only on forests. Obviously, ForDRI and USDM are not expected to be the same. However, the long-term severe and extreme droughts are highly correlated with the forest drought stress. For example, the ForDRI map in this slide shows severe to extreme drought over Louisiana and Mississippi forests at the beginning of this year. That was also observed on the USDM corresponding map. Overall, our analysis indicate that the long-term high-intensity droughts have significant impact on forests that are depicted by the ForDRI. This is an example, another example of side-by-side of ForDRI and the USDM maps for 28 November 2016. Again, you can notice that the long-term high-intensity droughts have significant impact on forests that are also depicted by the ForDRI over the Mississippi, Georgia, and Tennessee forests. What we have done next is comparing the ForDRI with ground observations, such as tree ring widths, so that we can perform quantitative analysis or evaluation. We use two independent ground observations for the quantitative assessment, tree ring and the bowing ratio. As you know, tree ring widths are measured to build tree ring chronologies and to estimate radial growth rates. Tree ring increment generally has a positive relation to rainfall of a specific season. So we use these data sets to evaluate our ForDRI model or products. I'll discuss the results in a minute. The second independent data set for quantitative approach that we use is the bowing ratio using AMI-reflex sites observations. This is the ratio of energy flux from one state to another by sensible heat. For example, a negative value of bowing ratio indicates that the latent heat flux, which is proportional to evapotranspiration, is greater than the sensible heat flux. These observed data sets are also considered to evaluate the ForDRI values. This slide shows the location of the sites we use for evaluation of ForDRI on the forest map produced by the U.S. Forest Service. We have used 33 AMI-reflex sites in red circle. That include 11 sites in the western and 22 sites in the eastern United States that we use for evaluation of the ForDRI. In addition, we have used 65 tree ring sites in green triangle with relatively longer historical records, more than 7 years. So for our evaluation of ForDRI, we used 57 tree ring sites data that are available in the Western US and 8 sites over the Eastern US. The results vary depending on the tree ring sites or locations or the forest region. For example, as you can see on this slide, the correlation between ForDRI values and tree ring width show encouraging patterns. The R values are 0.74 for one of the sites in Texas and 0.55 in Mississippi. In the bottom panels, you can see one of the sites in Oklahoma showed R value of 0.83, while it was only 0.43 in North Carolina. Even though the results are encouraging, we believe we need more sites comparisons to make a better or logical scientific conclusion. For that reason, we need more tree ring data that some of you may help us, especially with over the southeastern and southern regions. We don't have enough tree ring data sets to evaluate so far. This graph shows the percent correlation of the AMI-reflex sites in the eastern US with the range, the error bars. The y-axis shows the percent correlation and the x-axis shows the weeks in the growing season. This graph also shows which week the correlation is higher with p-values less than 0.1. The bottom two graphs are some examples of time series of the bowing ratio and ForDRI from 2003 to 2020. The rose color bars show the growing season. As you can see, the relationships are not perfect, but reasonably encouraging for these sites. Again, further specific studies or investigations are needed. To summarize my presentation, we have developed ForDRI models and maps for TGS US. For more technical details, you may see our journal article published for Eastern US on the right. If interested, we'll put the link in the chat box to download. Our plan is to pursue conducting more specific case studies that include focusing on forest types or species groups. In addition, we have planned to collect feedback from forest experts and managers like this webinar on the other forest regions. We'll continue the evaluation of ForDRI with ground observations, example tree rings and bowing ratio, so to improve the models. We would appreciate if any one of you could collaborate in getting ground observation data. or help us identify a better case study years and locations. We will also continue evaluating the performance and the capabilities of ForDRI maps as an operational tool. Finally, I would like to mention that we have a plan to investigate how ForDRI can be used to manage forest drought impacts, for example, wildfire, leveraging the ForDRI results. That's our future research plan that we would like to collaborate with some of you if interested. Now I'll stop and turn over to Ian to demonstrate the ForDRI dynamic viewer. Then Tanya will facilitate the survey and breakout groups. Thank you for your attention.
Thank you, Sagai. I will share my screen here. So this is the map viewer that we put together for the workshop. If you have used a map viewers in the past, any experience, it should be relatively intuitive. So I'll just go through some of the points here. So when you click on the link, I will put that in the chat here if you want to follow along. You can use your mouse to zoom in or the zoom in or out icons here at the lower right corner of the map. You can click the home button to return to default view. On the left, we have the map layers. We can show only deciduous forest. Those will be whited out. The conifers will be whited out, or you can only show conifer forest if you want. To get to the map layers, we can expand the arrow button here. For example, for 2024, you can click on and off available map layers that we have, and they will show. The map layers that are turned on, the topmost layer will only show, so just be aware of that. Next, we have the legend. Legend will show what map layers you have selected, and we have the ForDRI categories listed here as well. You can do a search by typing in an address or place if you want. It will zoom to that location. You can also get a lat long if you wish. Click on a location. You can copy that to your clipboard if you want that location. You can also use the draw tool. So for example, if you wish to zoom into an area, you can click on a polygon or a rectangle icon here. You can adjust the transparency, the color, and the line width here. So then all you have to do is click on the map, the area you wish to identify, double click on the last vertex to complete the polygon. Once we have that, we can print the map that we are showing now. All you have to do is click print, and you can see the results are working here. And there we go. Once you see this page icon, you can then click on that. It will open into a new viewer. And here is our map. You can then, depending on what browser you're using, you can just download it to your personal computer and save that. That will be saved as a PDF. You can change the base map as well. We have a base map gallery here with a number of options. And that is it for the map viewer. We then have a map comparison page tab you can go to. It works the same way as the previous map viewer, but these two map viewers are linked spatially. So if you zoom into one area, they will both show the same area on each map. You can change what you're looking at here. For example, if we wanted to compare November 6, 2023 with our current 2024 March 18th image, we can do that. And then you can pan and move the maps by clicking and dragging or by zooming in and out. So I think that's it for the map viewer.